It's my fault. Sorry.
Okay. So, you guys made the comment, pi over 6. And I agree with that answer. Is that the only answer? And I mean, I'm asking the question, so that kind of tells you, right? So how do we come up with other answers that will also make this true? We don't want to add
360 degrees, yeah.
Okay, but if we add 360 degrees or 2 pi, that's going to take us past our interval of 0 to 2 pi. Okay, so we only want angles that can be found in the first time around the circle.
Is it 330 degrees? Because you've already got 30 degrees because you're at
5 pi over 6. 5 pi over 6.
Okay, so I'm...
To get one time around, you have 330 plus, just 330 plus 30.
But we don't want to go more than one time around.
No, it's exactly one time around. If you're running 330 to 30 degrees, that's 360. That's exactly one time around. It's not more than one time around.
Right, but if you add 330 to 30, that puts you at 0. That puts you back at 360, which is 0.
You're right.
Which isn't making sense. Well, I'm hearing good ideas, so we just have to get them all put together. Okay? And so here in quadrant 1, you guys came up with the fact that sine is equal to 1/2 at the angle pi over 6, correct? And that is a positive 1/2, correct? What do you know about the quadrants here?
All students.
Okay, exactly what I need to hear you guys thinking about is all students take calculus.
This is its sine.
So we want to know, when does sine equal 1/2? So we already know, we've already got this one, yes?
Yep.
What other quadrant do I need to consider?
Sine.
My sine quadrant, yes, because that is where sine is positive. What about these two quadrants? No, because sine would be negative in those two quadrants. So then what you're looking at, over in quadrant 1, we do have the answer of pi over 6. What is the equivalent angle to in quadrant 2 to pi over 6? And this is where you want to think going off of the x-axis in terms of a reference angle. So if pi over 6 up in quadrant 1 is one of our answers, then on the other side, pi over 6 up in that other one. 5 pi over 6? Does that make sense, folks? Because if we look at our unit circle here, here's pi over 6. What is pi over 6 up over here? 5 pi over 6. And notice, we can even have a checkpoint here. What does it say here? The sine of 5 pi over 6 is positive 1/2, yes? If we go down and look in quadrants 2 and 3, negative 1/2. Excuse me, quadrants 3 and 4, negative 1/2, negative 1/2. Okay? So we have two answers of pi over 6 and 5 pi over 6. The comment I'm going to put here is that we are checking the unit circle for the values. Okay, that's how we're finding. We're thinking about that unit circle and looking at those. Okay? So questions about that problem? I mean, there's not really work to show, is there? And I understand that. Okay? But it's, where does sine equal 1/2? And if they're asking for positive, there's two quadrants where that happens. If they're asking for negative, There's likely 2 quadrants where that happens, right? Okay, notice this one, it was already solved. Normally we think about solving for x, right? Getting x by itself. This time it's more of a, how do I get sine x by itself? Or whatever trig function they give us. Okay, let's try 2. Our equation is cosine x plus 1 equals 0. First thought, if we want it to look like this one, where it was sine x equals a number, how do we make this cosine x equals? It's plus 1, subtract 1. So then I have cosine x equals negative 1. So at this point you're asking yourself, at what angle does cosine equal negative 1? And I guess the first thing I would say, did you guys go to the chart, try the chart first? And when does cosine, I don't know if I shouldn't have, dang it. When does cosine, if you just look at the middle 3, which is what's normally on your chart, when does cosine equal 1? Well, it doesn't at any of our normals, right? So what do you have to think instead for the 1s? Instead of thinking chart, think about the unit circle. And where did the 0s and 1s happen? On the quadrantal angles, right? At 0, 90, 180, 270, 360. Except put them in radians, okay? So the only exception to that is tangent can equal 1 at pi over 4 at 45. But other than that, the 0s, 1s with cosine sine, they happen at the quadrantals. So when does cosine equal negative 1? Well, cosine is your x or y value. X. When does cosine equal negative 1? At pi, correct? Because we know this ordered pair, left 1, up or down 0. And my work, so to speak, and again, not that there's really work here, is okay, thinking about, sorry, trying to get zoomed back in, is thinking about this, the fact that if we go this way, the ordered pair is negative 1, comma 0. And this is what angle? Pi. What you guys think of 180. So at pi, cosine is negative 1. Where else is cosine negative 1?
Nowhere.
Correct, nowhere. Okay. Did you guys look for the second one?
Yeah, that's like
And when it comes to the quadrantal angles, 1 and negative 1 are only going to happen once. Now, there are 2 places, like if it was when does cosine equal 0, there'd be 2 places. Okay. Got some of the beginning basics here. Okay, well, I'm ready to look at example 3 when you guys are. Cosine squared x plus cosine x minus 2 equals 0. I am going to have to veto moving the 2. And why? What's different? Why am I having to veto moving the 2?
that's fair.
Yeah, it's not now. If this was just a cosine x minus 2, sure. Or if it was just cosine squared x minus 2, sure. But we have a cosine squared and a cosine x. Now, we can't factor out a cosine because I don't have a cosine in every term. I will tell you, you do need to think about your algebra skills. I'll give you a hint here in a moment.
Well, first I was thinking maybe combine them in some way or try to eliminate one cosine from each one so we are left with just one cosine for squared one.
Cosine squared one.
Is there some way, since there's a squared, an x, and a c value that doesn't have a variable, are we going to have to do something crazy with like factoring?
It is Pythagorean.
No, it's factoring.
Oh, it's Pythagorean.
Okay, I'm writing this up above, but here's my hint to you. Okay, pretend the cosines aren't there. Okay, go back to your Algebra 1 days, Algebra 2 days. If we ignore the cosines for a moment, it's cosine squared x plus cosine x minus 2. So instead, think, how would I solve this if it was x squared plus x minus 2?
You factor out.
We wouldn't factor out an x. Because there's not a GCF.
Is. Right.
We are factoring though.
Is it factoring out of 1?
2 parentheses. Yeah. Think 2 parentheses. What does x squared break down into? X and x. What multiplies to be
1.
what multiplies to be negative 2
It has to be 1.
and adds to be 1. About positive 2, negative 1.
And then you solve those.
Yeah, 'cause
And then you know how to solve those, right? You would set each equal to 0. I'm stopping here because we're going to go back into cosine world. But we would set them each equal to 0, right? So where you'd have x plus 2 equals 0, x minus 1 equals 0, subtract the 2, add the 1. Okay, hold that thought. We need to go back to cosine world. Huh? Yeah, we need to. We have to, whether you like it or not. So, instead of saying x plus 2 and x minus 1, we are going to think 2 parentheses, x squared broke into x times x. Cosine squared x is going to break into cosine x times cosine x. So the front of each parenthesis in this trig problem is going to be cosine x. And then we're still asking the same question in what multiplies to be negative 2 and adds to be 1, which is the plus 2 and minus 1. Now, you can go think algebra and convert it to the x squared plus x minus 2 every problem if you need to. If you get to the point where you can think in terms of the trig functions, that's fine. But if you need to, always start here. Because basically, what did I do? These x's became cosine x's. I have 2 factors. Multiplying to equal 0. So we're going to set each one equal to 0. So I'm going to say cosine x plus 2 equals 0. Or cosine x minus 1 equals 0. Okay. So subtract the 2. Cosine x equals negative 2. If you want to go ahead, add the 1. Cosine x equals 1. And now we're kind of up to like problems 1 and 2, yes? At what angle does cosine equal negative 2? And at what angle does cosine equal 1? Those are the pieces we have to figure out.
Well, I don't think the negative 2 is on the chart, and 1 is just move 0.
Okay. So, struggling with negative 2 is not on the chart. Come back to that thought in a moment. And when does cosine equal 1? That does happen at 0 degrees or 0 radians, yes? Okay, so cosine equals 1 at 0. So when I write this x equals 0, that is 0 radians, if you will. Okay? I can't really put the degree bubbles because we're not working in degrees, but it's 0. So there's that answer. When does cosine equal -2? Huh? Never. Why are you suggesting never? Okay. Think about the graph of cosine. We just had a quiz over graphing cosine, yes? And where does cosine start? It starts up at 1, yes? And then what's it do? It goes down, and it has a minimum at -1. And then what's it do? Goes back up to 1. And then what? What numbers is it? Can I use the word oscillating? Is that an okay word? What numbers is it oscillating between? 1 and -1. When does cosine equal -2? It doesn't. That is outside of the typical range of a cosine graph. And so this one, there's no answer here. This one is not possible. But the other one had an answer, so we're still good on that one. Yeah, kind of.
Might be too early to speak, but I like going back to the circle.
You what?
I said it might be too early to speak, but I like going back to the circle.
You like going back to the circle?
I enjoyed this. It was fairly long.
Okay. Questions on 3? So shall we talk 4 then?
Yeah.
Okay.
Now there's 2, and we have to divide it by 2, right?
Yeah, now we have to,
Well, we just multiply the last term by 2. But
yeah.
Okay, so 2 sine squared x plus sine x minus 1 equals 0. Very similar to the last one, right? In that we have a sine squared term, a sine term, and a constant term, right? The difference, last time it was just an x squared plus bx plus c. This time it is an ax squared plus bx plus c because there's an a value out front. So you can think product of AC. This one actually is not bad to guess and check, and I know some of you cringe when I say that, but it is very doable. Regardless, for those of you sitting out there with a little bit of struggle, here's what I'm going to say. We're going to think, for those of you that need it, instead of 2 sine squared x plus sine x, 2x squared plus x minus 1 equals 0. That's what our brains are thinking right now if you need that algebra connection. And then we're going to factor that. Now, I heard product of AC, and that is perfectly fine. I'll be honest, in this particular problem, I wouldn't go product of AC just because the numbers are so easy. There's limited choices. When you look at 2x squared, what would 2x squared have to break into? Not x and x. What's 2 break into? 1 times 2, right? And so 2x squared is going to break into a 2x times an x. Yes? Right? 2x. In other words, normally x squared is 1x times 1x. 2x squared is going to have to be 2x times x. But there's no other options. It's not like it's a 6x squared where, oh, it could be 1 and 6. It could be 2 and 3. We could flip them. And here's what also makes it easy. What multiplies to be 1? 1 and 1. So the values at the end here have to be 1 and 1. Does that make sense? Now it's just a matter of putting the signs, positive, negative signs, in the correct locations. And I haven't even thought that far ahead. Is that what you have, or you have a question?
Wasn't they going to be negative because the middle term is positive?
No, because this last term is negative, which means we have to multiply to be a negative. So I need a positive and a negative. And so if my middle term is positive, I need the bigger sum to be a positive. Now, notice what our sums are. My outsides, if you think FOIL, right? My outsides are 2x times 1, which is 2x. My insides are 1x. So does 2x or 1x need to be the positive amount? 2x. And so how do I make 2x positive? It's 2x times that 1 there. This 1x in the middle is going to be the negative. Maybe for the benefit of the signs, I should have suggested product. I should have gone product of AC, but
You know, they were using the other way.
in my brain, I would have just written it down and I would have gone on with it. I wouldn't have taken the explanation. So, okay. We did that in terms of algebra, in terms of x's, right? What do you rewrite it in terms of now? Signs, because everything was in terms of signs. So one of our parentheses is 2 sine x minus 1. The other parenthesis is sine x plus 1. Okay. Algebra skills, what do I do?
Or no, you said you see it,
Set each factor equal to 0. So 2 sine x minus 1 equals 0. Or sine x plus 1 equals 0. On the first factor, I'm going to add the 1 over. So 2 sine x equals 1. Then what? Divide by 2. Yeah, think of it, if this was 2x equals 1. That's what you can always do with these is drop the sign off in a moment if you're thinking, I have no idea what to do. Drop the sign off, think basic algebra. So if we divide by 2, this becomes sine x equals 1/2. Okay. I'll come back and finish that in a moment. What's the other one going to be? Subtract the 1 over. Sine x equals -1. So those are the pieces we are answering.
so 3 pi over 2 is -1. Because that's what the sign
I don't know. I wasn't doing that one first. Okay. When does sine equal -1 is where Ross started. So sine is the y value. When is the y value -1? At 270, which is 3 pi over 2. Correct. So one of our answers is 3 pi over 2. The other question, when does sine equal 1/2? When does sine equal 1/2? Pi over 6. And where else is sine positive? In quadrant 2 at 5 pi over 6. So I have how many total answers here? 3. Pi over 6, 5 pi over 6, 3 pi over 2. And it doesn't really matter what order you write your answers in. You would just have to make sure you list all answers. So, yes, a problem could have 1 answer. A problem could have 2 answers, 3 answers. A problem could have more than that. 4, 5, 6 answers. It all depends on what we're doing. Okay. Questions on that one? Okay, well, let's move on to example 5 then. You judge it before you even get there.
It looks cool.
It doesn't have a number next to it, so it's already sketchy.
Where did the number 5 go?
Sketchy.
Okay, well, it works. Okay, so number 5, pretend there's a 5 there. 3 tangent squared x minus secant squared x minus 5 equals 0. Thoughts?
And it's also tangent and secant. So this one's closing out like
Okay, so yeah.
Sine and cosine, so it's the same term.
Okay, so observations. You guys observed. The big thing is the last 2 problems, it was all the same trig function, right? Which you can factor when it's all the same trig function. That's very doable. But we can't do a product sum factoring here when I've got a tangent and secant in the same problem. So, okay, we have all those identities at the beginning of this lesson, right? Those identities are still options. Okay, we're still using those. And we do want to make this so that we are all in the same trig functions. However, I'm going to not recommend going the sine cosine route on this one. I think that would just get ugly. I can't say that I've ever tried it, but the visions just don't look good to me. So, look for something that connects tangent and secant. Or specifically, something that connects secant squared and tangent squared. So we have a Pythagorean identity that connects these. Let's use it. The idea being, and we could technically do this either way. We could take tangent squared and replace it with whatever it's equal to in terms of secant squared. Or we could take the secant squared and replace it with whatever it's equal to in terms of tangent squared. Okay, but the idea is you're using a Pythagorean identity to replace. Now, I think part of it comes down to what does it seem like you'd be more comfortable working in? Do we want to work in an equation that is all in terms of secant, or do we want to work in an equation that's all in terms of tangent? I mean, those are things to consider. I honestly I've only tried it the one way, so. What would your gut say to work in terms of what? Tangent? And that's what I would say just because it's one of our main 3. I'm not saying you couldn't work in terms of secant though. Okay? So if we want to work in terms of tangent, we're going to use a Pythagorean identity. Remember how I like to put pi here. And we're going to replace it. So we still have 3 tangent squared x minus, what are we going to replace secant squared x with? 1 plus tangent squared x. And then we still have minus 5 equals 0. Now notice, it was secant squared. I replaced it with 1 plus tangent squared. Notice I put that in parentheses. More than anything, I put in parentheses because it's being subtracted. So, when we subtract that, in other words, if I remove the parentheses here, and you guys saw that what I did here, right? Like that was my Pythagorean identity. So if we rewrite this without the parentheses, 3 tangent squared x, what do we have here? Minus 1 and minus tangent squared x minus 5 equals 0. So all I did is distribute my negative there. Okay, can we go for like terms? Tangent squares can add with other tangent squares. Constants can add with other constants. Yes? So 3 tangent squared x minus tangent squared x is 2 tangent squared x. Minus 1 minus 5 is minus 6. Equation still equals 0. What'd you say? Okay. Notice we're at a point now where we just have one trig function, yes? Yes, it's a trig function squared, but it's just like working if this was 2x squared minus 6. That's what if you hit a confusion point, pull that tangent out for a moment, just say, okay, how would I solve this if it was 2x squared minus 6? Because those are the steps you're taking. So yes, I would agree, let's add 6 over to the other side. So then I have 2 tangent squared x equals 6. And then you would divide by 2, right? So if I divide by 2, I now have tangent squared x equals 3. Okay, if it was x squared equals 3, you would take the square root. Since it's tangent squared x equals 3, you're going to take the square root. What is the square root of tangent squared x? Tangent x. What is the square root of 3?
Wait, why are you not writing it down? Is it plus minus square root?
Oh, yeah, because you
Plus minus square root of 3. And say, fine, if you want to call me out on not writing it down, I'll write down square root of 3, but then I'm going to leave the gap indicating I need to put the plus or minus there. Rule still stands, right? When you take the square root in the equation setting, we have to allow for the positive and negative roots. Okay? So, we are at that point. It's tangent x equals plus or minus square root of 3. So, I didn't leave myself room very well here, but oh well, we'll just go into 6 and make it work. We are asking ourselves then, when does tangent x equal the square root of 3? And when does tangent x equal negative square root of 3? So, start with the basics. When does tangent x equal the square root of 3? Tangent, square root of 3, pi over 3. Now, officially, so I'm going to write down pi over 3. Tangent is positive in how many quadrants? 2. What do you know about the other 2 quadrants? It's negative. So what about this problem? We're going to have 4 answers, 1 in every quadrant. Does that make sense if I say that? Because, okay, so unit circle time. So here's pi over 3. What is the equivalent angle in quadrant 2? 2 pi over 3. So 2 pi over 3 is one of my answers. Technically, tangent's negative in that quadrant, isn't it?
Yeah.
So that's a negative answer, but it doesn't matter the order. I tend to go increasing order there. Okay, quadrant 3. What is the equivalent angle to pi over 3? No? 4 pi over 3, because you're going down pi over 3 from the x-axis. So 4 pi over 3. And what is equivalent in quadrant 4? Go down pi over 3 to 5 pi over 3. Okay? So we have answers of pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Nope, these are all angles between 0 and 2 pi. You should have no negative angles. because a negative angle would be going the other way, and the interval is specifically 0 to 2 pi. Yes. Wait, hold on. Go ahead, Shelby. Because we are looking to see in the other quadrants. So tangent equals, no! Tangent equals in quadrant. We've got to think about all students take calculus and how in different quadrants, we did it on number 1. On problem 1, when it was sine equals 1/2, we had to give 2 answers. But in that case, on number 1, when 1/2, my hand right there, so. Okay, homework will not be due tomorrow. I'll finish notes, and then I'll make it due on Thursday. Unless, of course, you're not going to be here Thursday. Don't try and turn something in after break.
When will we see our test grades?
Possibly tomorrow.
Okay. I feel like what mine could have been is I might have. Sorry.
Okay, did that answer the question, Shelby?
Levi, what are you asking about? To take the test?
Yeah.
Oh, okay.
I mean, you're looking at, in terms of when is tangent equal to positive square root of 3. If we think about, I'm trying to think the best way to do this. All students take calculus, right? So here, tangent's positive in quadrant 1, and it's also positive down here in quadrant 3. So we have to give, if our answer is pi over 3, we have to give whatever's equivalent to pi over 3 in this quadrant right here. And so, because in this particular problem, it was tangent x equals plus or minus square root of 3, because we took the square root, and so we had to actually do both. And so there were 2 answers for each.
I'm sorry, dude. You just got the most. Don't worry about it. Don't worry. Don't even look into it. Don't. Sorry.
Does that answer it there then, or? If you, well, I say, so you understood that tangent was square root of 3 at pi over 3, according to our chart, correct? And that's also, if I look at this ordered pair, that's also when this ordered pair happens, 1/2 comma square root of 3 over 2. Because if I were to divide these, I would get square root of 3. Okay? So now, when we look in the other quadrants, we're looking for when that also happens. And so like down here at 4 pi over 3, it's negative 1/2 and negative square root of 3 over 2. And so a negative divided by negative is a positive. So this would be our other positive angle of where it happens. And then since it so the idea here that it was tangent squared x equals 3. So then when we take the square root of 3 in an equation setting is plus or minus square root of 3. And so we had those 2 answers for the positive quadrant, positive square root of 3. So now when does tangent equal negative square root of 3? So now, right, and that's why you have to use your unit circle. So like, and that's why, so like here, it was pi over 3 over here, right? The equivalent would be going up pi over 3 here, and going up pi over 3 here from the x-axis. Up here would take us to 2 pi over 3. Something just clicked? Okay. Okay? Okay. You're welcome.